Hello, in this tutorial we're going to learn how to use inverses of a matrix to help us solve systems of equations. In our last video we learned how to find the inverse of a matrix, and now we're going to see how that can help us solve a system of equations. So in order to use the inverse, we need to rewrite this system of equations as a matrix equation. So we're going to have three different matrices basically, and the first matrix we call our coefficient matrix. And so we take the coefficients of our x and y, which in this matrix are a, b, d, and e. And we just leave that in order. So a, b, d, e. The next matrix is going to be our variable matrix. Well, that just carries the variables. Well, we have the x and we have a y. So there's my variable matrix. And lastly, our last matrix, our third matrix, is just the constant matrix. Well, that is what everything is equal to. And in order to use the matrices, we first need to be able to put this system in standard form. So now that we have this, we could find the inverse of this matrix. And let's call this matrix A. And we're going to call this coefficient matrix, let's say x. So we have a times x is equal to our constant matrix. So let's call that C for constant. Okay? A lot of times you'll see this formula written as ax is equal to b. So a times x is equal to b. Now, we don't really have a division property for matrices, but in order to solve for a variable, and in this equation we have the variable matrix is our x, we want to solve for x. So what we need to do is we need to multiply by the inverse of matrix A. Well, we know how to do that. Okay? So we can take the inverse of A and multiply it. If we do it to this side, we also have to do it to the other side. So A inverse. Now, when we do the inverse, multiply by the inverse of something, these reduce to what's called the identity matrix. And this is something we've covered in class before, so I'm not going to cover it in this tutorial, but this is just kind of help you to remind you. So we have the identity matrix times x is equal to, now I'm going to switch the order of this because it's kind of important that we have to have it in order, because remember, multiplication is not commutative. So A inverse times C. Now, remember when we solve for an algebraic expression, the identity matrix is basically like writing a coefficient of 1. We don't really have to write the 1x. So this identity matrix kind of goes away, and so we're just left with x is equal to A inverse times C. So this is the basic process of solving a system of equations using matrices. So let's go ahead and let's do an example of it. So if we have the system of equations, let's write it as 2x minus y is equal to 12. I'm sorry, I'm going to do another one. This one's not going to come out to a very good solution. So I'm sorry, I was writing down the wrong one. Stick with me here and I'll get it right. Okay, so let's do this one. I have to write with my tool here first. So let's do this system. We have x minus y is equal to 3. And we have 2x minus y is equal to a negative 1. So the first thing that I need to do is I need to write it in matrix form. So again, set up your coefficient matrix. So the coefficients of x and y. So we have a negative 1, or 1, negative 1, and 2, negative 1. Then I'm going to have my variable matrix. Well, I'm just given the x and the y variables, so there's 2 of them. And then lastly, my constant matrix, so the 3 and negative 1. So, what I need to do, I need to find the inverse of my coefficient matrix. Now, we learned how to do that in our last tutorial, so I'm going to go through this real quick. So again, we multiply it by 1 over the determinant. So the determinant is going to be 1 times negative 1, which is negative 1, minus the product of these two. Negative 1 times 2 is negative 2. So we have negative 1 minus negative 2. Well, when we subtract a negative 2, we're going to add 2. So negative 1 plus 2 will give me 1. So this works out real nice. Notice that this fraction is just 1 over 1, which we know is just 1. So we're going to take 1 times, and remember now we mix up this fraction a little bit. So we're going to switch these two numbers around. So we're going to take this negative 1 up here, this 1 down here. So we're going to have negative 1 and 1. And then we flip the signs or make these two terms opposites. So it's going to be a positive 1 and negative 2. And now we do scalar multiplication. Well, this is easy because when we multiply anything by 1, it's itself. So our inverse of that matrix will be negative 1, 1, and negative 2, 1. Now, we're going to take this matrix and we're going to multiply both sides of this equation by it. Now, normally, if you've done this right, we don't have to show this whole step, but I want to show you and show you kind of what happens. So we're going to take this times 1, negative 1, 2, negative 1, and then we have our variable matrix is equal to, and again, now this is why you need to put this in front of the constant matrix. This is a 2 by 2 matrix, and this is a 2 by 1 matrix. If we were to do 2 by 1 times 2 by 2, notice the inside values are not the same, we couldn't do it. But if we have 2 by 2 times the 2 by 1, our inside values are the same and we'll get a 2 by 1 matrix as the resultant. So it's important that you put the inverse in front, so negative 1, 1, negative 2, 1, in front of the constant matrix, so 3 and a negative 1. Alright, now let's do the multiplication. So I'm going to come over here first, do these together first. And I'm going to go ahead and do it rather quickly, so try to stay with me. If you need to pause it and get stuff written down, write your notes, just do it. That's fine. We're going to take this times this plus this times this. So negative 1 times 1 is negative 1 plus 1 times 2 is 2. So negative 1 plus 2, 1. Go to the second column. Negative 1 times negative 1 is 1 plus negative 1. Well, that's going to give me 0. Alright, so now I go to the second row. Negative 2 times 1 plus 2. So negative 2 plus 2, 0. Negative 2 times negative 1 is 2. Plus 1 times negative 1, negative 1. So 2 plus negative 1 gives me 1. Notice this is my identity matrix, the 1, 0, 0, 1. This is exactly what I wanted because basically this is like the coefficient of 1 here. And so now I can write my constant matrix. So again, this is a 2 by 2 times a 2 by 1. These are the same, and I'm going to get a 2 by 1 matrix here. So let's go ahead and do this pretty quickly. Negative 1 times 3 is negative 3 plus a negative 1. That'll give me negative 4. Negative 2 times 3 is negative 6 plus negative 1 is negative 7. And so there I have it. There is my answer. The top is going to be my x. So x equals negative 4, y equals negative 7. And so I'm going to show it as a coordinate, negative 4, negative 7. Remember, the solution to a system of equations is the point at which the two lines intersect each other. Hope you enjoyed. Thanks for watching.